In this video, we are going to look at how to add and subtract vector quantities, how to find the components of a vector quantity, and then look at kinematic equations and how kinematic equations can be used to solve the problems when an object is moving with a constant velocity, either horizontally or vertically, and then finally to the projectile motion. So say for example, there's a velocity vector A and the velocity vector B, and we have to add them. We have to add them like vectors. So draw A first and then B. And then from here to there, that will be the result of these two together. It doesn't matter if you draw B first and then A. It is the same answer because it's the same direction and same size. To find the size of this resultant vector or resultant velocity, you will have to use Pythagoras, and to find the angle, use geometry. So that was about how to add vector quantities. Now, to subtract vector quantities, so if this is vector A and this is vector B, and we have to find A minus B, a vector C, which is A minus B. So negative B is a vector which has the same size but opposite direction. So we'll draw B first, which is opposite to that, and then draw A. From there, we add negative B, which is this one. And then this will be the resultant, which is A minus B. Now, unlike when we add vectors and A plus B comes out same as B plus A, it is different. So we have to look at which vectors has to be subtracted. So if we're trying to find B minus A, so that is B, and this minus A, and answer is this one, which is a vector and similar in size, but in opposite direction. So the answer to A minus B is this one, and thus the answer to B minus A. If we have to find the component of a velocity, then say, for example, this is the velocity. A plane might be flying at a certain velocity, and that's the angle with the horizontal, and we have to find its vertical velocity and the horizontal velocity. So if you look at this triangle, then this one is same, equivalent to this one vertical velocity, and this is the adjacent side of a triangle. So that will be, we will be using cos theta. So horizontal velocity, or Vx, will be velocity V times cos of theta, and this one over here, which is the opposite side in this triangle, will be this velocity V times sine of theta. So that's how we can find the component of a vector or of a velocity vector. Now, kinematic equations. There are two types of motions, linear motions. A motion when an object moves with a constant velocity, and the motion when an object is moving with a constant acceleration. So with a constant velocity, it's V equals d over t. But with constant acceleration, these are three kinematic equations: V final, V initial, acceleration, time, and distance. In each equation, there are four quantities. You will be given one, and you have to find the fourth one. So these equations can be used when a car or something is accelerating in a horizontal direction, or something might be moving up or down with an acceleration. Then acceleration will be the acceleration due to the gravity for the vertical direction. Otherwise, for horizontal motion, acceleration will be given, or you can find out by using one of these equations. Remember, if something is decelerating, that means it has got a negative acceleration, then this value of A will become negative before you use this equation. Now, main use of these equations is in a projectile motion. So let's look at an example of a projectile motion. So for example, a ball was thrown at a certain angle with a horizontal. It follows this path and hits somewhere over here, or comes back to the ground level. So if we look at horizontal component horizontal. This vertical velocity has two components, v horizontal and v vertical, all through the motion. If you look at the horizontal velocity component, they're all have the same value, or horizontal velocity is constant. Reason being, there is no friction in air, or it's so small that we ignore it. However, because there's a gravity force acting, so while the ball is going up, vertical velocity is decreasing, vertical component is decreasing. And then at the very top, vertical velocity becomes 0, but it will still have, that's the middle part, it will still have the same horizontal velocity. So we cannot say that in the middle velocity is 0, only vertical velocity is 0, but horizontal velocity will have the same value. And as the ball comes down, because now it's moving in the same direction as the gravity is acting, so ball will be accelerating, or vertical velocity is increasing. When it hits the ground here, because it has traveled the same distance up and same distance down, and acceleration due to gravity was same. So therefore, this vertical component will be same as that one, but horizontal velocity remains same. So that means this velocity with which it hits the ground, it will have the same size as that one. So if it was thrown at this angle with 12 meters per second, this will still be 12 meters per second. And this angle over here will be the same as the angle with the horizontal, but obviously directions are not the same, directions are different. So to solve these type of problems, first of all, you need to calculate the vertical component and horizontal component as I mentioned before. So vertical component is always velocity, which is this one, times sine theta. Horizontal component is velocity times cos of theta. So that's the first thing that you need to calculate. Then quite often we divide it into two parts. So first part is this part of the projectile motion. So we can calculate the time using one of the kinematic equations, because if we know the initial vertical velocity, and if we know the final vertical velocity over here is 0, we know gravity is g. So we can use one of those equations over here, v final and v initial, when you know the acceleration due to gravity while going up will be negative 9.8. So we can calculate time using this this equation, the top one. The first thing is to find the time. Now, another thing is the time for the upward flight is same as the time for the downward flight. The total time of the flight will be whatever time you've calculated to go from here to there, and then double it. That will be the total time. If we need to find out this distance, horizontal distance traveled by the ball, then because horizontal velocity remains constant, so v horizontal multiplied by the total time will give you the horizontal velocity, horizontal distance traveled. If you have to find the vertical height, then obviously when the ball is going up, it's decelerating. So then you can use one of those equations. So if you were given an initial velocity, and you've calculated the time, you know the acceleration, so you can calculate the distance traveled in a vertical direction. So for projectile motion, we divide the velocity into two parts, horizontal component and vertical component. For a horizontal part, we use constant velocity equation. For vertical part, we use kinematic equation. And these are the same. And remember, for upward motion, acceleration is not negative 9.8, and for the downward motion of the ball, the acceleration will be plus 9.8. So that was all for this video. Thanks for watching it.